Okay, so before we do the workshops, we're going to talk about background data and DEMs. So in WMS, when you're working with WMS and really with any GIS, WMS, I wouldn't consider WMS necessarily a GIS, but you can use a lot of GIS data inside of WMS. And you're going to be using you're going to be working a lot with GIS data. So if you've had experience with GIS, then it's definitely a plus in working with WMS. So we're going to talk about projections. We call them projections. Some people also call projections coordinate systems, or yeah, so projections or coordinate systems, just where you, some system to define where you're located on the Earth. And we're also going to talk about DEMs, digital elevation models, and what we mean by DEMs in WMS. So this is all part of the data collection step. So that we're kind of starting with this first step, data collection. And then we're going to move on to talk about DEM-based delineation. We're actually going to skip this map-based delineation. Map-based, you're going to use some map-based delineation possibly if you're working with urban areas. In urban areas, that's where you kind of need to learn about map-based delineation. There's workshops online on Aquaveo's website that will teach you some of the concepts of map-based delineation. But for this course, we're just focusing on DEM-based. So a lot of times, if you're working in a rural area, you're going to be doing a DEM-based delineation. And that's all you really need to do if you're working in a rural area. If you're working in an urban area, you could start with a DEM-based delineation, or maybe you have really good elevation data. It might give you a good DEM-based delineation. But you might have to modify it based on roadway embankments or things like that. So that's where map-based delineation comes into play. But we're going to start out by talking about data collection, how to get data into WMS. And to do that, we first need to talk about projections. And with projections, the main thing to keep in mind is your data, all the data you have, if you're doing a real world model, and some people might have like a flume model or something they're doing, like if you're doing a hydraulic flume model, in that case, you might not be working in a specific projection. But if you're doing a real world model that's somewhere that's modeling some part of the world, you're going to want to work in some kind of projection. And the data you collect is going to have a projection, but also you're going to be working in a projection. You either need to get your data into the projection you're working in, or you can just work in the projection your data is in. And the thing about WMS is some of the data will automatically be reprojected to the projection you're working in for you. Some of the data will not be reprojected. So what you want to do is decide on a projection and try to make sure that everything lines up, all your GIS data lines up in that projection. And by a projection, there's two classes of projections, and one class of projections is called a geographic projection. Geographic just means latitude, longitude. And there's different datums that are used for geographic projections. Some of the more common ones, especially in the United States, there's something called the NAD 83 geographic datum. And then there's other ones like the WGS 84. The 83 and 84 is just the year that those projections were created, that those datums were created. So that's geographic latitude, longitude. Geographic is just latitude, longitude projections. When you're working with the watershed model, you don't want your data to be in a geographic projection. You'll have to project it to what we call a planimetric projection. Planimetric is just an XY plane, just a Cartesian plane or Cartesian grid, that is defined as just a projection, where you project as part of the Earth onto a plane, a planar surface. And some of the more common planimetric projections are what we call state plane projections. So in the United States, it divides the state plane. Every state has a series of projections that are used in different parts of each state. And these are some projections that are used in California, Nevada, Utah, Arizona. So these are the state plane systems in those states. Another common worldwide projection is called the UTM, or Universal Transverse Mercator projection. And this projection divides the world up into 6-degree intervals. And then you can defines which projection you're in based on which of those 6-degree intervals you're in. So like here in Oklahoma, for most of Oklahoma, you're in UTM zone 14, as you can see here. And that's between 102 degrees and 96 degrees west longitude. And so those are common projections, planimetric projections, and you're going to want to get your data all into some kind of planimetric projection. The other thing with GSHA is you want to make sure your data is in metric units. So if the projection you're working in has to be in meters. A lot of the state plane projections will be in feet. You can use the state plane projections with meters, but you want to make sure you use a metric state plane projection and not a US feet or a international feet state plane projection. The way you define your projection in WMS is by defining the display projection. And there's just a menu in WMS that you'll learn about in the workshops, where you define your display projection. And that's the projection that you're working in. WMS is going to attempt to convert all of your GIS data. If it has projection with it, it's going to attempt to convert it to your display projection. If WMS doesn't, if it can't convert it, like if it's a 2D grid, which it can't, WMS can't convert 2D grids, or if it doesn't know the projection of your data, then it won't convert your data. So you'll have to manually tell WMS what the projection is and convert it to the correct projection, the display projection.
Yeah, and if you bring in all your data and it doesn't work and you go back and check this projection. It's like the first thing. You pull in all your data, just go check your projection and make sure it's where you think it is. That is oftentimes. And if your data are 100 feet apart, you look at them and then you've got your projection wrong. So this is like really critical. The only comment I can make.
That's right. So Steve has had the experience where things didn't line up. And if things don't line up, he's just saying, make sure that your projections are set correctly for all of your data. And most likely they aren't set correctly if things aren't lining up. And like I say, so WMS will attempt to project some things on the fly, and that's what this is talking about. This slide is just mentioning that WMS will attempt to reproject everything on the fly. There are some things that it cannot project on the fly, and one of those is your 2D grid. So when you create your 2D grid, like I say, you want to create it in your display projection. Just make sure that you're in meters, because you can't reproject your 2D grid in WMS. And that's what's used for your GSHA model. You just want to make sure that's in the correct projection. So this is an example of what Steve was talking about. So you might have soil data here. So you might have soil data that's in geographic units, land use data that's in state plane units, and DEM data that's in UTM, but not units, but in a state plane projection, and DEM data that's in a UTM projection. They don't line up when you bring them in. They may not line up when you bring them into WMS. So to get them to line up, you'll just have to make sure that the projection is defined for each of these data sets. And if it isn't, then there are ways of reprojecting your data to the correct projection. And we can, you'll just have to get experience with getting everything in the right projection. But this is the window in WMS where you can reproject data, and there's certain data sets that you're allowed to project from one projection to another. That's called reprojecting your data. A lot of times, though, like I mentioned, the data should be projected on the fly. So WMS, if it knows what the projection is, it's going to automatically show things in the correct location if you've defined the projection for each data set that you have. Okay, so the question, we have a quiz question. This is for you, Chuck.
I don't even need to see.
Why must we know the coordinate system of our data? A, so we can make correct calculations of area, distance, slope, etc. B, so we can convert to another coordinate system if necessary. C, so that we can accurately overlay one layer of data with another. Or D, all of the above.
All the above.
Yeah, so I think we've kind of talked about all these things. So it's all of the above. All of the above. There you go. Okay, another question. Which coordinate system or projection would not be effective as a display projection? A, state plane. B, universal transverse Mercator or UTM. C, geographic. Or D, all of the above could be used as a display projection. Which would not be effective as a display projection? This is a trick question because I said all of the above. Always the answer. So somebody was making a sign over here.
Sorry. See.
Okay. It's C. So the correct answer is geographic. Why? You know why geographic would not be effective as a display projection? Yeah, it's not a planimetric projection. It's latitude, longitude. You cannot define a GSHA model in latitude, longitude coordinates. Or maybe you can. There's no way to do it. Yeah, so you can't.
So you gotta convert it.
So you'll have to convert any data you have. You have to make sure your grid is not in geographic. You have to make sure your grid is in some planimetric projection. You could probably make a grid in WMS in geographic, but it won't be right. Your model won't work. It might work, but it won't be right.
Worst case scenario.
All right, so WMS can be used to bring in base maps, and we're gonna look at some of these things. I'll show you. So it has some nice, WMS has some nice features that you can use to bring in background data, background base maps and things. Also, if you have something like this, maybe you have a drawing of a construction site or something, you can bring in CAD data into WMS and just view that CAD data. You can also bring in GIS type of data. So shape files, if you have shape files or things like that, you can bring those in and just as a background reference map. This is an example of a watershed that is displayed on top of an image, and there's different like shading features. So WMS, you can show contours and contour maps of your watershed or whatever. And there's different features that help you to make pretty pictures of your watershed. You can also take your data from WMS and export it to some other program, like either to CAD or to a GIS program, and then make a map in CAD or GIS. It has this tool that allows you to bring in an online map. And by an online map, I'm talking about Google Maps. So you can bring in a Google map into WMS. Also, it has Esri maps that you can bring in that are just available from Esri's web services. And Google has its own web services that you can use those background maps in WMS. And also the USGS has web services, as well as well, it's probably just all the USGS. So the USGS provides land use and elevation information that you can get directly from WMS. You can bring in GIS and CAD data. Now we're going to kind of talk a little bit about DEM data. And there's two classes of DEM, digital terrain data. One of the classes of data is called TINs, which is just scattered XYZ data. And these yellow triangles you see on the screen here that's just a TIN. So a TIN is just a bunch of scattered XYZ data that's connected by triangles. And WMS can be used to create TINs just from survey data. So if you have somebody that goes out and does a survey, gives you some XYZ survey points, you can bring those into WMS. And this is kind of important back in the 90s, I guess, when we first created WMS, because there wasn't a lot of elevation data that was readily available to people. And so we would use TINs a lot. But then so also there were DEMs back when WMS was first created also. So WMS also supports something we call DEMs, which is just a regular set of elevation points that are set to a grid. And in WMS, most of the time you're going to be working with DEMs. And that's what you're going to be using for doing your GSHA models, or any of the models really in WMS. You're going to be working with DEMs. And the nice thing with DEMs and TINs, in WMS you can convert from DEMs to TINs and also convert TINs to DEMs. So whatever you have, and also LiDAR data, you can convert LiDAR data to DEMs or probably to TINs also. But I would usually just convert the LiDAR data to a DEM. DEMs are gridded elevation data, and these are some of the common formats for DEMs. You have USGS DEMs, ArcInfo, ASCII grids, GeoTIFFs, which are DEMs. And then there's a bunch of other formats. And DEMs are in a class of GIS data called raster GIS data. So rasters are just data, and I call this class of GIS data, I just call it rasters. And rasters are GIS data that are set to some kind of gridded points. They're gridded points. They're not scattered points. They're gridded points set to some kind of grid. That's raster data. In WMS, you can use this get data from maps tool to get to DEMs. And the way you do that is you select the get data from maps button. It brings up this window where you can define what part of the world you want to get data for. You select the data source. And there's two data sources. In the newest version of WMS, there's actually two data sources. One is this worldwide elevation data, which is maybe a data set that's about 4 or 5 years old that is available for anywhere in the world, that allows you to get elevation data at different resolutions. And the resolution depends on where you've selected the data. The maximum resolution depends on where you've selected the data, where you're getting data. The other is in the newest version, 11.2, I think. I don't think 11.1, WMS 11.1 has it, but there's a 3DEP, which stands for 3D elevation program data, that's available from the USGS. It's another web service that's available in the newer version of WMS. And that's more accurate data usually that's available in the continental, and maybe also in Hawaii and Alaska, maybe just anywhere in the United States that data is available, the 3DEP. You get your DEM from online data, and then you can just use it directly in WMS. Now, one thing to keep in mind when you're working with DEM data is the resolution of the data. And you want your data to be a high enough resolution to get the elevations you need, but you want it to be a low enough resolution so you don't bog down your computer. If it's too high a resolution, then you're gonna spend a lot of time delineating your watershed. The watershed delineation will take too long, and also just creating a GSHA model. A lot of times, if your GSHA model is too high a resolution, it's going to take a longer time to run your GSHA model. So you want to think about your resolution of the data you're downloading. WMS has this option to tile DEMs, which isn't as important now because I can just download a seamless DEM from web services now. So I don't have to tile DEMs usually. You can also trim DEMs. So if I download too large of an area for DEM and I want WMS to run faster, I can trim my DEM, make it run faster. And then there's different display options. So I can display contours in different ways. So these are linear contours, and the different colors represent different elevations. And these are color-filled contours. And there's something called the display step that I don't know that we're going to get too much into that. It doesn't really matter anymore. But so the workshops, Aaron, do they have workshops is there a download site for the workshops, or are we just going to use the Aquaveo?
We're going to use the Aquaveo.
Okay.
The GSSHA wiki was not cooperating me at 2:30 in the morning.
Okay. We can do the Aquaveo. Okay, so the workshops that I would recommend doing, there's this introduction to WMS workshop, and to get the workshop, you just click on this PDF and it'll download the workshop. Anyway, that'll kind of introduce you to the WMS window, and you can get this data, this zip file has the data. And then you'll also want to probably do the projections and coordinate systems workshop. And that'll help you learn about projections and coordinate systems. I think we have, those are the two we had on the schedule. So introduction, and he had images. So the images one is kind of out of date. So there is this images workshop. So this one actually might be a good one. The first part of it anyway will show you how to download an online map, and so that'll be useful. The second part, you're going to register an image, and I wouldn't even bother with the second part where you register an image. It's too much trouble, and you probably won't need to register an image, but if you ever do, you can just come to this workshop and register an image. Well, that registering an image, that just means defining the coordinates of an image, so the image lines up in whatever projection you're working in. And
Paper map.
yeah, but nobody does that anymore, right? So we're gonna skip that. You don't need to do the registering. If you want to, you can do the first part of this images. Do the introduction, do the first part of the images, and then do the projections and coordinate systems, just so you can learn about projections and get everything in the right projection.
The only thing I would say about registering images, sometimes you get a site plan that's a paper copy that they give you. You're gonna wanna bring that in, so you are gonna wanna register that
Okay, so
by hand.
sometimes you might have to register an image.
So there's cases where you do.
Yeah, then you can go do that tutorial like.
Yeah.
But most people aren't gonna want it. But you can do it.